Hello everyone, these are the three most voted on problems that you wanted to see a video of. So it's going to be number 14, 19, and 21. So we're going to start with number 14 here. It's 3 plus 4 ln 2x equals 15. So the first thing you're going to want to do is subtract 3 from both sides. That goes away. You're going to have 4 ln 2x equals 12. Now you're going to divide both sides by 4, and you're going to get ln of 2x equals 3. Now this is where most people get stumped. What you want to do is you want to rewrite this ln as log base e. Because remember, ln is log base e. So we can rewrite ln as log base e. 2x equals 3. And now it's a question that we did in the early sections of the chapter where we're just rewriting e to the third equals 2x. And from there, very easy to solve. Divide by 2, and x equals e to the third over 2. And you can either leave it like that or put it in your calculators. All right, number 19. So it says, according to the U.S. Bureau of the Census in 2000, there were 35.3 million residents of Hispanic origin living in the United States. By 2010, the number had increased to 50.5 million. The exponential growth function, all right, so they give us a function to start with. A equals 35.3 e to the kt. Describes the Hispanic population, A, in millions, T years after 2000. So the first thing we're going to have to do is find K. Now, they give us some information in this problem. They say that in 2010, the population is, what do they say, 50.5 million. So this is really like a Y value, and this is really like your X value. So we're going to plug those into the function and do 50.5 equals 35.3 e to the 10k, and I have 10 because it's years after 2000, so 2010 would be 10 years. Now I'm going to divide 35.3, divide 35.3. If you do 50.5 divided by 35.3, let's see. We got 1.43 equals e to the 10k. From this point, you're just going to ln both sides. Which is ln of 1.43 equals 10k divided by 10 divided by 10. And k equals 0.036. So we have our model is A equals 35.3 e to the 0.036 t. That is going to be the model. So that's all for part A. So this is part A. Let's do part B. Part B, it says use a model, calculate K to project the Spanish population in 2015. So this one's nice and easy. 2015 is just 15 years after 2000. So we're going to use our model. A equals 35.3 e to the 0.036 times 15. And you should get about 60.6 million. You could put that right in the calculator. That can go right in the calculator. So 35.3 e to the 15, about 60.6 million. Lastly, part C, it says in which year will the population reach 70 million? So now 70 million is like your Y value. So it's going to be 70 equals 35.3 e to the 0.063 t. Remember, we're solving for t because it says in what year. So it says in what year, so that's why we're solving for t. So we're going to divide by 35.3. 35.3. So I'm going to use my calculator again. 70 divided by 35.3, about 1.98 equals e to the 0.036 t. And we're going to ln both sides again. So we have the ln of 1.98 equals 0.036 t. Divide by 0.036. T equals the ln of 1.98 divided by 0.036. And I'm going to use my calculator here. Notice that when I type it in, I'm closing the parenthesis off and then hitting the divide. So this would be about 19 years. So that would be in year 2019. So that is number 19 in its entirety. All right, the last one we're going to go over is number 21. That's Newton's law of cooling problem. So I just wrote the formula here, and we're just going to go over each part. This T on the outside is the ending temperature. This C is the constant temperature of the surrounding area. This T sub 0 is the initial temperature. There's C again, your E, and K is your constant. Remember, since it's cooling, your K should be negative, and T is time. So the first thing says write a model. So to write a model, we need K. So we're just going to go from this formula and we're going to plug in everything that the problem gives us. The problem says you serve a cup of coffee that has a temperature of 185 degrees. The room temperature, let's break it down. So 185 degrees, that's going to be our T0. Our C, keep it consistent. Our C is going to be the room temperature. So that's 65. The K, we don't know yet. The T is going to be, what does it say here? The temperature of the coffee is 155, so that's going to be 155. And after T minutes. So for this one, it says after 2 minutes, it's 155. So little t is 2. So now we're going to plug it all in. So we're going to have 155 equals 65 plus 185 minus 65 e to the k times 2. Now we're basically plugging in an x and a y to find k. So we're like using a data point to find k. So first thing I'm going to do is I'm going to simplify what's in the parentheses, and I'm going to subtract 65 from both sides. So we subtract 65 from both sides. 155 minus 65 is 90. So 90 equals, now I'm going to simplify what's in the parentheses here. 185 minus 65 is 120. So I have 90 equals 120 e to the k times 2. I'm going to divide by 120. 90 divided by 120 is 0.75. So I have 0.75 equals e to the 2k. And now I'm just solving like we always do. ln both sides. So that's going to be 0.75 equals 2k divided by 2, divided by 2. And k equals, when you put it in the calculator, you should get something like negative 0.1438. So that means your model is T equals 65 plus 120 e to the negative 0.1438 t. And that is your model. And this is all for part A. And now we'll do B real quick. So part B, it says, when will the temperature of the coffee be 105? So when is the temperature going to be 105? So we're solving for when, that's time t. So 105 equals, right into your model, 65 plus 120 e negative 0.1438 t. And we're going to solve minus 65 minus 65. That's 40 equals 120 e to the negative 0.1438 t divided by 120 divided by 120. That's a third. 1/3 equals e to the negative 0.1438 t. We're going to ln. So I'm going to have the ln of a third equals negative 0.1438 t. Finally, I'm going to divide by negative 0.1438. Not t, just negative 1438. And time equals the ln of 1/3 divided by negative 0.1438. So we go to, I'm a little off center, sorry. We go to our calculator. I'm going to do the ln of 1/3 first, divided by negative 0.1438. And you should get about 7.6. 7.6 minutes. Oops. And those are the three problems.